'Cause I love you, baby, and if it's quite alright, I need you, baby, to warm my lonely nights. I love you, baby. Trust. We live yet, Jerry? All right, straight up, brother. Hey guys, welcome back to the 48th episode of the Swift and SwiftUI Learnalong. I am your host, Yosoi Oat, and for the uninitiated, quick intro. This is the stream where, true to its namesake, it's a learn along, meaning I'm not teaching you something where you're a fly on the wall watching me learn something, except I am narrating the entire experience to you and obviously sharing my screen. So any code samples, anything along those lines, anything interactive that can be read or viewed, you're getting that full experience. But of course, along with that comes all of my maybe preferred nuance, maybe not so preferred. But the point is, it's a raw learning experience, and so let me just tell you the positioning of the stream thus far. So we started with the Swift portion. So now we're firmly, we're firmly in the SwiftUI portion. We've already went through a book called The Big Nerd Ranch Guide for Swift Programming, 7th edition. Great book, by the way. 818 pager. It's a thick one, thick, 2 C's. But we're done with that. So we've got a very detailed, technically, I mean, I would call it an overview, although it was a ton of information. But we just worked through every aspect of the language, did the code samples and all that, put together some. We have this board here that I'm keeping track of with effectively all of the concepts that I found to be a bit challenging or that I needed better understanding of. So my thought is that over time, I just collect all of those things here. So this is just SwiftUI, but all of this is the Swift stuff, a whole bunch of conversations with the Oracle, with Gemini, whatever. So this should be a good learning resource. I'm going to share this with all you guys once I clean it up at some point. But I figure not a huge benefit currently, because I know there's some redundancy in there, and we're not done with the SwiftUI portion yet. But this will be available to everybody, and this is where I'm keeping it. And then aside from that, what the hell was I saying? Oh, yeah. So the general idea of the stream is I started a company. I want to build an actual product that I intend to sell. It's not going to be open source, but I am streaming the entire process, right? So learning Swift, and now SwiftUI, which is the portion that we're on now. And you know what? Maybe I should just, if I was perhaps, okay, what happened here? Yeah, why don't I just add it to the board, and then I should have done that a long time ago. Then I don't have to say it every time, or at least I can talk you through a visual while I say it. But yeah, so the general idea is, give me a, well, I'm so indecisive about the damn shapes. Anyway, okay, so first, step one, right? Step one is, why does it look like that? Oh, there we go. Okay, so Swift deep dive via actually, let's do this. Deep dive in resource used is the Big Nerd Ranch Guide, 7th edition. And this is, okay, good, I can do that. So this is done. What is that? Okay, I didn't want to do that. Just want to make it bigger. Okay, so this is done and all available on on YouTube channel, which is Nico Narration. So if you want to go back and watch those, I'm still going to hold true to my word at some point to chop those up into a more, cut out all the fluff, like stuff like this wouldn't necessarily help you learn Swift. So eventually I will chop up all of those streams, but we're talking about 45 episodes that it took to get through that book, which is roughly 45 times 3, 135 hours of content. So it'll take a little bit of time, but either way, the recorded streams, you can always just fast forward. But because the whole time the book is on the screen, so I mean, it should be decently achievable to scrub through the video and see the parts that I'm, step away for the bathroom or showing you some other tool on screen versus if you just want to jump back to the book. So it should be pretty easy, but either way, myself or Jer, we're going to edit those at some point. So this is done and all available on the YouTube channel. Just make sure you go to the live section, not the videos, because you won't see anything, or you'll maybe see like one or two. But just go to the live section and you'll see all of those, right? And then now we've moved on. Let's do a new shape. How about that? This shape looks a lot like, I don't know if you guys played, obviously I'm a big fan of Halo, my other stream, but that looks just like those ranked, whatever, I'm nerding out. All right, so, but step 2 now. Step 2 is the Swift, this is what we're currently on, SwiftUI Compendium, that's the name of the course, and we are not done with this, but similar to, how can I just, same thing goes here, right? Man, are you kidding me? Actually, hold on one sec. BRB, I have to go take care of something. This is, what is it, 1 o'clock? 1:10 p. CST. Yeah, sorry, I did not time this well, but be right back. Nights I love you, baby. Trust in me when I say that I'm back. Trust in me when I say that I'm back. Whew, okay. Sorry about that. My fault, cousin. God damn it. Okay. A little early, so that's good. Sorry about that. Once again, now. Oh wait, I wanna, yeah. Man, that's really killing me having that. What did I have on this key here? Yeah. Oh well, not important right now. Okay, so SwiftUI Compendium, that is the the graphical aspect of things. So writing graphical, is that the word? Graphical user. How about just GUIs? That's why we just say that anyway. GUIs, user interfaces. And so after we finish this, we're going to work on some. So step 3 will be 2 things. So the SQL schema for SQLite onboard storage on the device. And I decided I would like to use GraphQL just because it's not going to be a big app anyway. And, well, I'll say that. You never know, but whatever. I want to use GraphQL because I like it. And so we're going to use that for the API, for the backend API. So we're going to design some of that to some extent, not full on, but for whatever makes sense after the fact. So that'll be some brainstorming. We'll get to use some cool tools to help us do all of that. And then after that, that won't be long. So step 3, maybe, I don't know. I guess I could put that there. So I don't want to spend any more than, 1 to. We will be going back to the books. So it'll be Big Nerd Branch Guide on iOS programming, which is their recommended follow-up to the Swift Big Nerd Branch Guide. So this will focus more on the Apple APIs, whereas the first book was more a deep dive into the Swift programming language itself. So this will be paramount, and we should gain a lot of understanding here. And then as a last step, we're just going to roll into trying to build the thing, just doing it on stream. You dig? So that'll be the last step. And then at this point, we'll probably start building the app. So that'll be MRP Panda. And then also look at a low level option, either C or Odin. It'll be one of those two. But I would like to have a decent understanding of one of those just in my bag, so to speak. You know what I mean? So I haven't decided yet. I'm leaning Odin, honestly. Because I feel like if I learn Odin, just by virtue, I can learn C or vice versa. But I don't know. Odin to me seems very attractive. So, and it actually has, the real reason is it already has built-in integration with Metal, Apple's lower level GUI framework. So, which is a big deal. I think maybe V is the only other language I know that has, or they can boast that, but that's through it's through a different library. through their own library, and they just write bindings to metal, so it's it's different, obviously. But yeah, so that is the plan for the stream. So obviously where are we at? We're over here. So we have a ways to go. But if that sounds like something you want to stick around for, then drop a sub, brother. Okay, but other than that, let's get cracking. So Xcode. We actually didn't get into any code yesterday or the day before. It's been a lot of reading, which is fine. I mean, it's been good information, don't get me wrong. But yeah, eventually we should get into the actual sample project, which there is one associated. So that's what this groceries project is. So we are going to get there. But got to do the boring stuff first. But no, really, it's not boring for me. I just think it maybe the code not being on screen is not as engaging. But too bad, brother. Okay, so now learning can't always be fun, but mostly it is. Mostly, at least on the output, on the back end. It is pretty painful though, starting out when you just kind of like reading Chinese, All right, but anyway, this is where we left off. So we're gonna pick it up right here. So 3.1 of the SwiftUI Compendium, creating the model data to feed to the SwiftUI views in your app. Nearly every app interface operates on data. With very few exceptions, your app's interface must display data or allow user interaction. Data is modeled using basic Swift types familiar to programmers. These types are available for your apps through the Swift framework, which is thoroughly documented here. Okay. Which we won't go to that link just yet. We've been there a million times. Modeling the app's data using Swift's enum structures and classes. The Swift standard library encompasses several topics helpful in app development. For instance, it covers methods for adding, removing, or reordering elements within collections. Okay. Within this framework, we discover two valuable guides. The first is the Maintaining State in Your Apps article, demonstrating the utilization of Swift enums to represent mutually exclusive states. That sounds fancy. Maintaining state in your... Okay, so let me save this to board mix. There we go. Wait, the first Maintaining State in Your Apps article demonstrating the utilization of Swift enumerations to represent mutually exclusive states. Okay, so just not one state machine perhaps, but two to have a start off point or a kickoff point for initializing the application. Cool. However, this isn't a rigid rule. It doesn't mandate enclosing your entire app state within an enum. Instead, it showcases its utility in representing specific aspects of it. The entire app within an enum? That sounds pretty cool. Well, I won't get derailed. However, this isn't a rigid rule. It doesn't mandate enclosing your entire app state within an enumeration. Instead, it showcases its utility in representing specific aspects of it. Following that, the Choosing Between Structures and Classes article explains when to use structures or classes to represent your app's data. It suggests defaulting to structures, aligning with the approach in all the SwiftUI tutorials linked previously. Okay, good. Yeah, I don't want to use classes. This is the approach this course will adopt as well. Thank goodness, yeah. That really is good news. Okay, so then... while I often present multiple types together within code snippets. Let me see how long these are. I'm not sure if it'd be beneficial to read these first. Let's just see what... Oh, wait, I forgot about my bad. This is my favorite thing to brag on Edge about. Oh, yeah. Okay, so... Can your browser do that, brother, natively? No, it cannot, because you're probably using Chrome, and I feel bad for you. All right, maintaining Maintaining state in your apps. Use enumerations to capture and track the state of your app. Overview. Effectively managing state. The bits of data that keep track of how the app is being used at the moment. Yeah, that's a decent definition of state. Not that I can do any better, but it's always a kind of a wiggly definition. But yeah, it's quite literal if you think of it in the use case of, like, say you're the president of the United States and there's like a big commotion going on and it's 3 a.m. So you just woke up and you rush into the, whatever that secret, what's that? Not the Oval Office, but whatever. Let's say it's just the Oval Office. You rush into the Oval Office, everyone's already there. And you say, General, what is the state of things? Think of it that way. What is the state of things? What is, well, I don't know how to get any lower level than that, but I think you know what I mean. Everybody kind of gets that reference. And that's state within a program, except the state is represented by data. And so kind of like the state of the browser right now, like whenever I hover my cursor over this left side panel and the panel expands, that's state. Like that flipped some flag somewhere to, you know, panel expand equal to true. And then there's some kind of event listener. So when I pull off the panel, and then it automatically switches it to false and it collapses. But that, I mean, that's state. That's part of what state is. So the state being, this is now flipped to true versus being false, you know, all that stuff, all of it. It being split screen, the fact that I have it split where the top, you know, is like an eighth or what is that? I don't know, a third. That's not a third, a fourth maybe. A fourth of the screen to the top tab and the rest to the bottom. That's also state. So just literally the state of things. Okay. At least that's how I like to think about it. So it is an important part of developing your app because enumerations define a finite number of states and can bundle associated values with each individual state. You can use them to model the state of your app and its internal processes. Use an enumeration to capture state. Consider an app that requires a user to log into an account. When the app is first opened, oh wait, I meant to look at, oh, that's not bad at all. We'll read this. Yeah. We'll read this. Consider an app that requires a user to log into an account. When the app is first opened, the user is unknown. So the state of the app could be called unregistered. Okay. After the first user has registered or logged into an account, the state is logged in. Yeah. Yeah, see, I guess you could even refer to it as status, although that term kind of falls off with its usefulness in other contexts. After some time of inactivity, the user session may expire, leaving the app in a session expired state. Okay, yeah, that's a good example. You can use an enumeration to specify the exact states needed for your app. Yeah, it makes a lot of sense when you think of it that way, because if the session is just starting for the first time, it would make sense, you know, the default state being, you know, unregistered, not logged in, not authorized. Yeah. Let's see. This person finds an app class with a nested state enum that includes only the specific states that you need. So here's a class, but we'll use a struct. So the app itself. So this would represent the totality of the app, everything in scope, which would be everything in this example. And then here's the enum state, and then the different cases that it can be in. So either unregistered, logged in, or session expired per user. And then we have a variable state of type state, and it's equal to, yeah, unregistered, which would be its default value, which makes sense for an app where you need to log in and supply credentials. So in this model, each state is represented by a case with a matching name. The logged in and session expired cases include the user as an associated value, while the unregistered case doesn't include an associated value. When you update your app state, there's a single variable state to modify no matter what the transition. No matter what the transition. Okay. Recommended. User opens app. So, oh, I see. Okay. So when they open it, the state should equal unregistered. Yeah. Makes good sense. Don't spread state across multiple variables. It's also possible to model an app state by using individual variables in combination to hold the state and the required data, which is not recommended. Why not? In this model, the app defines two variables, an optional user that stores user info, and a Boolean value named session expired. The user variable is nil when the user not logged in. What is this grammar? The user variable is nil when the user not logged in and has a value once the user logs in. Okay. The session expired variable begins as false and is set to true if the session expires. The three states are captured by different combinations of two variables. Using this approach is prone to mistakes for a few reasons, in ways that can lead to bugs and make it harder to reason about your code. For every change in state, you need to provide updates for both user and session expired in tandem. If a future change to the app requires an additional state, you need to update an additional variable at every existing change in state, and the two variables have an unused combination. It's possible to set the user to nil and session expired to true, even though that doesn't have a corresponding state. Okay. So I suppose the takeaway is just, if we use this approach, they're recommending you keep it all inside a single enumeration with case statements to represent the different possibilities of state, but the actual state should reside in a single variable is their is their recommendation. So on the bottom, by the way, this is the Apple Docs, the official Apple Docs. So that's who's recommending that, not me, not whoever wrote this other course, but yeah. All right, following that, choosing between structures and classes article. So yeah, let's read through this one. All right, choosing between structures and classes. Decide how to store data and model behavior. Structures and classes are good choices for storing data and modeling behavior in your apps, but their similarities can make it difficult to choose one over the other. Not over here, brother. It's gonna be structures. So we don't have to fuck around with inheritance. Consider the following recommendations to help choose which option makes sense when adding a new data type to your app. God damn, I'm trying to scratch my back, can't get there. Use structures by default. Consider the following recommendations to help choose. Oh, these are the recommendations. Okay. So they suggest structures by default. Use classes when you need Objective-C interoperability. Hopefully that day never comes. I know nothing of Objective-C, but by looking at it, I'm happy I know nothing of Objective-C. Use classes when you need to control the identity of the data you're modeling. I don't know what that means. To control the identity. Use structures along with protocols to adopt behavior by sharing implementations. This is what we're going to do, because we effectively, the Big Nerd Range Guide, this was their default recommendation also, which is good. And we saw a lot of examples of this. We saw a lot of class examples too, but lots of structures and protocols, which I really liked. So yeah, I mean, this is what we're gonna do, but I would like to understand what this means. So let's go ask Gemini right fast, brother. What is meant by the start below on SwiftLang in relation to controlling the identity. In Swift, identity refers to the uniqueness of an object in memory. Two objects are considered identical if they refer to the exact same instance in memory. Right, yeah, understand that. Classes and reference types. Classes in Swift are reference types. This means that when you create a class instance, you're working with a reference, like a pointer, to that object's location in memory. When you assign a class object to a variable or pass it to a function, you're essentially copying the reference, not the entire object, right? Controlling identity with classes. Classes give you control over identity because multiple references can point to the same class object. Changes made through one reference affect the object that all references point to. This is essential when you need shared state. If multiple parts of your code need to access and modify the same data, a class is the way to go. Okay, object mutability. Classes allow you to change the properties data. Okay, so I guess that's, but I mean, object mutability, you can get that with structs too. I guess it's not really resonating with me. I understand this point, and this makes a lot of sense. I just don't see how that correlates to controlling the identity. But okay, whatever. But let's see. So structs versus classes. Yeah, I don't know. But I get what they're saying, but I don't get the correlation or identity, but okay. All right, so choose structures by default. Use structures to represent common kinds of data. Structures in Swift include many features that are limited to classes in other languages. They can include stored properties, computed properties, and methods. They can include stored properties, computed properties, and methods. Right. Moreover, Swift structures can adopt protocols to game behavior through default implementations. The Swift Standard Library and Foundation use structures for types you use frequently, such as numbers, strings, arrays, and dictionaries. Using structures makes it easier to reason about a portion of your code without needing to consider the whole state of your app. Because structures are value types, unlike classes, local changes to a structure aren't visible to the rest of your app unless you intentionally communicate those changes as part of the flow of your app. As a result, you can look at a section of code and be more confident that changes to instances in that section will be made explicitly, rather than being made invisibly from a tangentially related function call. What? As a result, you can look at a section of code and be more confident that changes to instances in that section will be made explicitly, rather than being made invisibly from a tangential. Oh, okay, I see. Yeah, because you're making a copy, so you can be sure that it's isolated to that instance and not affecting some other part of the code that's also pointing to a class, because a class is a shared instance in memory. Okay, hold on. Also stay hydrated. Yeah, good idea, baby. Yeah, the door's unlocked. Use classes when you need. Objective-C interoperability. If you use an Objective-C API that needs to process your data, or you need to fit your data model into an existing class hierarchy defined, whatever, we don't need to do that. All right, use classes when you need to control identity. Oh, good, a fleshed out explanation. So classes in Swift come with a built-in notion of identity because they are reference types. This means that when two different class instances have the same value for each of their stored properties, they're still considered to be different by the identity operator. This means that when two different class instances have the same value for each of their stored properties, they're still considered to be different by the identity operator. Oh, because they're not value types. Okay, I see what they mean now. Yeah, because they're not well, we learned this. So they're not equal because wait. Oh, right, yeah. So the references to the singular instance are unique, therefore they don't equal one another. So there's two different pointers. They're pointing to the same thing, but those two pointers are not equal. And therefore, that would come out as false. So they're not really the same value, technically speaking, because inside the bucket is not the value they're pointing to. It's just the pointer itself. Okay, it also means that when you share a class instance, which again, part of the reason why I really just don't want to fuck around with classes, but because then you don't have to deal with this stuff. But at some point, I mean, we'll likely have to, just for performance reasons, but hopefully not for the most part. It also means that when you share a class instance across your app, changes you make to that instance are visible to every other part of your code that holds a reference to that instance. Yeah. Use classes when you need your instances to have this kind of identity. Common use cases are file handles, network connections, and shared hardware intermediaries like CB Central Manager, which I don't know what that is. Callback, maybe? For example, if you have a type that represents a local database connection, that the code that manages access to that database needs full control over the state of the database as viewed from your app. It is appropriate to use a class in this case, but be sure to limit which parts of your app get access to the shared database object. Yeah. Okay. Or just, yeah. I don't know about that, but maybe it's different with iOS. That's in web dev, I know there's a lot of times where it's helpful to not do that. And then on the SQL side, you can just set up a connection pool or something like that. Important, treat identity with care. Sharing class instances pervasively throughout an app make logic errors more likely. You might not anticipate the consequences of changing a heavily shared instance, so it is more work to write such code correctly. Yeah, which is why we won't start with classes at all. Use structures when you don't control identity. Use structures when you're modeling data that contains information about an entity with an identity that you don't control. In an app that consults a remote database, for example, an instance's identity may be fully owned by an external entity and communicated by an identifier. Which would be my case, yeah. Yeah, because if we're going to be pulling in, say, data tables referencing a name, we don't have, I mean, we'll make copies and bring it in locally into some kind of sandbox environment, but yeah, I mean, that would be the app. Or the app's use case in my context. If the consistency of an app's models is stored on a server, you can model records as structures with identifiers. Yeah, that's what primarily I did when I was writing Go. There was a lot of that. But yeah, I mean, if you're working with a SQL server and you know the schema, that just makes sense, So then you can have your type safety. Even over the wire. In the example below, JSON response contains an encoded PinPal record instance from a server. Okay, here's a struct, a value type called PinPal record. We've got a constant, my ID, it's an integer, mutable variable, my nickname, it's a string, and a recommended PinPal ID integer. Okay, and then my record equals try, so that means it can throw. JSON decoder. So we attempt to create an instance of the JSON decoder, chain the decode method against the PinPal record contained in the instance of the struct we created from JSON response, which I don't know. I guess that comes from elsewhere. What would that be? That would be a parameter in decode. Yeah, you pass it the... Yeah, okay, so we just don't know what that is, but some parameter for the decode method. Maybe a file, maybe? Whatever. Or we would capture that request in some variable and then pass it in. Local changes to model types like PinPal record are useful. For example, an app might recommend different PinPals in response to user feedback. Because the PinPal record structure doesn't control the identity of the underlying database records, there's no risk that the changes made to local PinPal record instances accidentally change values in the database. For example, an app might recommend multiple different pen pals in response to user feedback because the pen pal record structure doesn't control the identity of the underlying database records. There's no risk that the changes made to the local pen pal record instances accidentally change values in the database. Yeah, I get that, but I guess that's why I just don't get the focus on saying the identity of something. I don't know. It's just still not resonating, but I get what they're saying. If another part of the app changes my nickname and submits a change request back to the server, actually, but then again, I mean, on my end, to me, you should write SQL to interact with your data, not. That's just my opinion, but I mean, I don't think you should have application code fucking with your database at all. It should just, you should be writing SQL, and that should all be handled with with SQL stored procedures, or just having a sanitized raw SQL in your app code. I mean, that's what we're gonna do. So maybe some of this, that's why this doesn't apply, but or it doesn't resonate with me. But yeah. Okay, use structures and protocols to model inheritance and share behavior. Structures and classes both support a form of inheritance. Structures and protocols can only adopt protocols. They can't inherit from classes. Yeah. However, the kinds of inheritance hierarchies you can build with class inheritance can be also modeled using protocol inheritance and structures, which is a big reason why I chose Swift, because I didn't want, although classes were there, this was really the main thing, or the selling point that pushed me over the edge. The fact that you can match any functionality that classes can give you using a combination of structures and protocols, which just leaves classes more or less as a, God, I can't get, my ass is not fitting here. So I like this because that means classes is still an available tool for those instances where you don't want to necessarily make copies because it's too much overhead, so. And then we also learned about final class, which is basically a way that you can use classes but restrict anything else in your app potentially inheriting from that. So effectively restricting the creation of subclasses. If you're building an inheritance relationship from scratch, prefer protocol inheritance. Yeah. Protocols permit classes, structures, and enumerations to participate in inheritance, while class inheritance is only compatible with other classes. When you're choosing how to model your data, try building the hierarchy of data types using protocol inheritance first, then adopt those protocols in your structures. Yep. All right, good. So that was helpful. All right. It suggests defaulting to structures, aligning with the approach in all these SwiftUI tutorials linked previously. This is the approach this course will adopt as well. I didn't mean to do that. Adopt as well. Writing code and organizing Swift types in an Xcode project. We'll commence by creating custom types that will serve as data for our views. While I'll often present multiple types together within code snippets for convenience, ew, it's all melty. I did leave it. Yeah, I did. Okay. My practice is to place each custom type into a separate .swift file. Named after the type it contains. Really? No, I like that. Okay. I mean, that makes sense. This approach facilitates the creation of a preview for each view we generate. Oh, okay. I'll prefix each type with a comment displaying the file name. All right. To understand more about adding files to a project, refer to the Managing Files and Folders in your Xcode project article. Okay. we might actually learn something because I have had a few struggles with Xcode, not gonna lie. Managing files and folders in your Xcode project. Add new. Oh, okay, hold on. Okay. The project navigator displays your project's files and lets you open, add, delete, and rearrange those files. To open the project navigator at the top of your project, and click the icon that resembles a file folder. Okay, so we're familiar with that. We've seen that quite a bit already. When you select a file in the navigator, the inspector pane displays information about the file. Okay, I'm gonna, some of this stuff is not new at all, so let me not waste time here. Add new files to a project. Yeah, we did that. Control click and select new file. Control click for what? In the new file sheet, select a template. Okay, we've done all that. Some templates require you to specify additional info for the new file. For example, the Cocoa Touch template asks you to specify information about the class you're creating, including the parent class name. Xcode uses this information to populate the file with some initial content. Xcode, yep. Okay. Tell me about the tell me about the groups. Where is the when Xcode prompts you for the file's location, it also asks you to specify group and target info. The group indicates where in your project to place the file, and Xcode selects a default group based on contextual info. Okay. Xcode also selects a default target, making any relevant changes to the target and group values, and then click OK, create file. Yeah. Create groups. Create a group structure in your project that matches the structure of the selected field and folders on disk. Xcode creates a group in the project navigator for each folder you add. Okay. So if you just want to do it by directory, then you can do that. And that's probably what I would do. Until it got maybe a lot bigger, but that's not a concern right now. Create folder references and adding a local Swift packages folder to your project. Add. We did do that. I'm not gonna dig into that currently. To use Reality Kit content that you create using Reality Composer Pro, you can add its folder to your Xcode project and link against Reality Composer Pro. That sounds cool. I'll resist though. Organize projects. Delete. Xcode uses the source code to perform the operations and track the changes. If you move files between groups in the same Git repo, Xcode moves the files in the file system. If the files are in different repos, Xcode copies the files into the folder in the new repo. Okay. Yeah. Mostly not new information, so let's move on. Do you understand more about adding files? Oh yeah, we did that. Okay, one type per folder. Okay, so I see what you mean. So in the comment, he'll have the name of the file, even though it might be one singular code sample. Okay, makes sense. I strongly recommend typing the code I present. Doing so will help you solidify the concepts you'll learn. Yeah. And we have been, and we will. There's a strict no copy paste rule unless we're just stuck. But yeah, on this stream, no copy and pasting unless it's a last resort. All right, or unless I'm going into the Oracle. But as far as like code samples and putting it into Xcode, that's all manual. It really does matter. I mean, it helps you to learn, even if you think it might not. But I suppose the best example of that, or the best way to prove it, is go ahead and, try to learn just by watching, and then go open up an editor and see what you can actually write with no one telling you what to do or anything. and then you'll figure it out pretty quickly. Okay, read the editing source files in Xcode. For further guidance on writing and organizing code. Okay, let's see what else they can ramble on about. No, not really. Structure is always an interesting. I'm trying not to sneeze. Shoot. Damn it. Set up your Xcode project window to efficiently edit multiple related files. At the same time, set up your Xcode project window to efficiently edit multiple related files at the same time. What do you mean same time? Like multi-cursor? While you edit, annotate your files so you can easily determine a file's content with the minimap or jump bar. No, I hate the minimap. Hate it. Then add comments that Xcode can present as quick help to make your code easier to understand. That sounds helpful. I like that idea. For information about how to add files and folders to your project, see, okay, we did that. Edit related files using tabbed windows. Yeah, this is the part. I mean, look, let's be honest. macOS in general, just there's a lot of good things about it. Window navigation, tabs, anything with navigation or windows are not one of them. It just sucks, to be honest with you, comparatively to Windows and Linux, honestly. To open a new window tab with the same config as your current window, press Command T. Wait, to open a new window tab with the same config as your current window, press Command T. What do you mean? Okay, so let's do it. Command T. And I got a new tab. Oh, I didn't realize. So when I do, oops, god damn it. So when I do, that switches tabs within the window, but not the window itself. Why is it doing that? Fucking thing. Okay. Command tab. Okay, but how do I switch windows then? Well, I don't know. I don't know that I'll need multiple windows. I'm good with the tabs, honestly. Okay, so let's go back. They might tell us anyway. Okay, Command T. That's good to know. Didn't know you could also have windows and tabs per window. So that's nice. New window tab. Here's the open editor. Wait, what? Oh, yeah, that's automatic. You just click it and it pops up in the main window, so that makes sense. Okay. Next, configure each tab for how you plan to use it to give each tab a name that describes how you use it. Choose window, rename window tab. That's my thing. I don't want to be clicking around. I'm not trying to go full Vim on anybody, but a lot of that just seems, I don't know. We won't dig into it here, but show or hide, click and adjust. Okay, I mean, I guess that could be cool. You have one view with the sidebar open, maybe another one with collapse. Yeah, I don't know. From the navigators, click a file to open. Edit your source code. To open a source code file, just click it. Yep. And we're familiar with the autocomplete. It's, for the most part, been very good. That's appreciated. When you use code complete for a method or function with parameters, Xcode provides a placeholder. Yeah, so this has been the coolest part about it, honestly. When it pulls in the parameters for you, and then you can just enter, tab to the next one. That's been really helpful. For common code structures. Yeah, because matter of fact, I mean, I've had obviously autocomplete and other things, but none of them did that specifically, which is nice, letting you tab through the parameters. For common code structures, Xcode provides snippets you can add to your code. Click the library in the upper right, library snippet, and select a snippet. To add some code for the snippet, control click. Oh, okay. So yeah, I knew about the snippet, although I should use it more because it is quite handy. But where is that? It's not that. Nope, not that either. Code review. I don't know what that is either. Where was the show library? Oh, here we go. Okay, the little plus button. What is that? Yeah, so this is really nice because kind of like, I mean, I don't know that it's, I mean, it does, there's no better. I was gonna say, I don't know what's better, but it's just yet another resource. But yeah, I mean, this is really nice just to see quick examples. Yeah, I need to remember to use this. So I think over time, what I've realized as far as just like editors, in general, a lot of the pain can be mediated with any editor that gives you something like this, or even if you just had a markdown file. But if you, like, over time, just keep track of the code you write, and with each unique, chunk of code that you might reuse, if you just put it in one place, it doesn't take too long. And then before long, you have a very nice library of things, very relevant to your workflow that you can just draw on. And then a lot of the pains of, that we refer to in, oh my gosh, what? Oh my gosh. Yeah, this is even better. I was going to say, I don't know what to use, this or the other thing, but the other thing I'm referring to is I've had this thing forever, even before I really was trying to program, but now it's very useful. It's called Code Recipes Pro, and they have like a ton of, it's not just for Swift. Like if you go to languages, like they have all these here. You can only show X amount at a time, but it comes with all of these. And this is basically all of your majors, right? And then tons of good examples. So all the different kinds of types, structures. So this is pretty sick. And it was cheap. I think it was $10 for a lifetime license. And I've had it for like 5 years. I used to just use it for SQL when I would, if I needed a reminder how to do something. But yeah, it's a great app, and they've kept it up to date. Like, for example, all of the, what do you call it? The, not LTE, LTS. Whatever the LTS is, they've always kept it up to date. Like right now, Swift 5.9. It's got Swift 5.9 examples. So yeah, shout out to Code Recipes Pro. Check it out if you just want, I don't know, the peace of mind of always having high quality code snippets on hand for effectively no affiliation, by the way. I don't even, yeah, it's just, I'm just a consumer, I swear. But yeah, it's nice. I mean, they're not cheating you. You know what I mean? I feel like this is absolutely worth $10, but I need to take these and put them in Xcode as I draw from them. That might be nice to do. And let's see. That might be a good stream too. Maybe we'll just go one day just through all these examples. Actually, yeah, I am going to do that because these really are great examples. And then I can share them on the board mix. Yeah, okay, now I'm thinking. All right, there we go. So anyway, that's the snippet thing, and that is cool. I like that. I like that in Xcode a lot. And it looks like this is the thing that always gets me though. Like where, once again, Mac OS Windows, like where did that, yeah, it's just gone. I didn't really tell it to close, but here, let's do that again. What does that do? Makes it tiny. Okay. What does this do? Oh. Yeah, it's always been a weird relationship with Apple stuff. Like on the one hand, it's really neat. They do stuff just differently. And some stuff, it's nice. Other stuff, not so much. But yeah, this is really handy. Just the fact that all this is in the editor. I can't stress enough that most of the time, like most other languages, okay, you're not going to get this kind of help from your editor. Not in a nice, neat package like this. You'll get docs and whatnot, and you'll get help from disparate locations. But when you have the editor and the language tightly packed into an ecosystem like Swift and Xcode, you can have stuff like this, which is nice. But I think other platforms have it too. I'm not saying it's the only one, but yeah, it's hard to find it neatly packed like this. Like this is kind of reserved for big JavaScript frameworks, Java, Go. Kind of, you could maybe say that about Go a little bit, but Go doesn't have like a dedicated GUI, library, so that it's very very different experience. But anyway, I digress. So let's go back to this. Anakin your code for visibility. Annotate your code for visibility. The jump bar and the minimap each provides a quick visual way to navigate your code in the Xcode source editor. Yeah, how do you do this with mark, fix me, and to do? Oh, good. Yeah, I was wondering where this stuff goes. And I don't know, I haven't seen these, so this will be cool. Annotate your code. Oh, they just mean with oh. Jump bar. Okay, let me save this one. This is good. So mark, to do, and fix me, colon, and then the jump bar is okay. Within the, okay, so let's look at that. Sweet. All right, so in the comments, I can do, let's put this at the bottom. Or it doesn't really matter where I put it, but so I can do mark. Hi. And do I have to put a space? I don't. Hello. And then what was the other one? To do, and goodbye. All right, and then in the jump bar, so all the symbols, that's pretty badass. I like that a lot. I like it a lot. And then here's our, it even shows you where in the hierarchy. Man, that's really nice. I mean, come on. With a flag, a band-aid for the fix me. Okay. How charming is that? How about that? They really I think if nothing else, you can't deny Apple really brings the smoke when it comes to the visual aspect of things, which is appreciated. All right, so that's really cool. I like that. Now that I know where those are, I can I need to make a sticky note just to use them. That's the hardest part. Like you come across cool shit all the time, but for something to actually make it into your workflow, I don't know why I'm doing this, but this is how I describe it. Something to actually make it in your workflow. It's got to be, it's got to be, well, A, it has to be good enough. It has to inspire you to add it, but then B, you need the discipline to implement it until it becomes second nature. Add a mark comment to add a heading section to a section of code. Include a dash in the comment to instruct Xcode to show a divider line between the section in the jump bar and minimap. What? Wait, add a in the comment to instruct to show a divider line before the section in the jump bar. Well, let's see what that looks like. So if I add a dash here, then what happens? So body. Oh, that little line right there versus. Oh, okay. I kind of like it without it. I mean, they have their own little logos, so maybe I'll change my tune when this gets bigger. But I like that. That's helpful nonetheless. So let me. Why is it doing that? Wonder if it doesn't. Come on, bro. Well, whatever. Let's just do this. I just want to save that little piece there because that is handy. And oh, I don't have it open. Board. And so, boom, boom, boom. And where is SwiftUI section? Yeah. Which one is the caption? Caption. Label? No. There we go. I do want to pin it. Oh yeah, where'd it go? Annotate. I guess because there's nothing in it. Hopefully that's why. This is for marking or code organization. Yeah, labels might be better, but okay, I wanted something there. All right, cool. So mark, add a to-do comment to indicate where you want to do future work. The jump bar highlights the to-do comment with an icon for easy identification. Add a fix me comment to note where you need to fix. Need to make a fix in your code. In addition to the organizational benefits, consistent use of mark to do and fix me comments improves your ability to search for common sections, future updates, and needed fixes. Yeah. Add quick help comments to your code. View quick help comments for a symbol by selecting it and choosing View Inspector's Quick Help. Alternatively, control click a symbol and select Show Quick Help. Right, so that's another awesome thing we saw that is helpful. If we just do, we need to pick a Swift type. So control click on View. Or wait, maybe it was. Oh, not command click, control click. Show callers. Oh, that's, yeah, this is awesome. I can show all the callers. There's the GD and show quick help. Refactor, find, navigate, fold. Oh, sick, you can fold it. Yeah, this is nice. All right, so let's see. Show quick help. So that gives me the context, but if I just option click, I get the same thing. Yeah. Huh. Okay. Oh, they did say control click. I just didn't read that right. All right. Add quick help comments to your code to clarify usage for other developers. To add quick help to a symbol in your code, hover over the symbol declaration, command click it, and choose add documentation. Oh wait, I gotta see that. Okay. Control click. Add documentation. Oh, I thought it was gonna pull in. Okay, well that's okay. Still gotta do some work. All right, so that. No, that's cool. Cool with me either way. All right. I mean, you could just, but what is the significance of the triple backslash though? Xcode adds lines of comments preceded with triple backslash that have placeholder value or that have placeholders for a description, parameters, throws, and a return value. I see. That's what it's for. Depending on the symbol declaration, update the placeholders using markup syntax to complete the comments and enable quick help for the symbol. Oh, sick. I can use... Really? That's cool. Let's see. Let's do it again. Add. Oh, whoops. So. Bullet. Does this work too? Triple. Like all from. And then I can. That's fucking awesome. That's. Wait. Oh no, yeah. Okay, so overview. So it didn't take my. I guess maybe it doesn't take. Maybe header one is always. I just want to see if it can take a subheading. Well, that's view, but what about this? So show. Go. Okay, so the maybe it can only take one. Just trying to see how far this sub heading. To what extent I could use this. I don't know why, but I've always just this whole idea of nested documentation, but not just like comments, but actual formatted markdown wrapping everything. I've always loved just that thought in general. You can do it. Okay, so if I guess my question then is why did where'd the overview go? Why is that not there anymore? Whoops. Killing me, dude. Come on. Show quick help. Yeah, weird. I'm not sure how it establishes. Hey, babe. I'm not sure how it establishes how that looks. How was it? Huh? I don't know. Making light conversation, brother. She's hilarious. Uh, um, oh, right. Yeah, how do I... I guess it doesn't really fucking matter, but it showed overview at first. Maybe that's only in the absence of... Or how about this? Maybe if I just do just an empty one. Okay, how is it moving? And I'm not fucking pressing any kind of directional input. It's really getting on my fucking nerves, but... You see what I'm saying? Well, you can't have nice things on... Okay, I'm not going to press anything. Control. Okay. Show quick help. Yeah, I guess the top level is always... Or you can replace it, but it's not going to show both, is my guess, but that's okay. Either way, this is exciting. Okay, but if I leave an empty... I didn't mean to do that. If I leave an empty one, now overview is back. But even without this, I would get that, correct? Yep, okay. But for some reason, you can't replace the single header. Like normally that would be your H1 in Markdown, but that just gets cannibalized by overview for whatever reason. But you can use it, or you can just replace it, but oddly can't have both, I guess. I wonder if you can do this, say overview, and then a thing, and then it's not, there we go. I need a space. Oh, I wonder if that's why. Maybe. Overview, a thing, header. Okay, I think I just needed a space. All right, sorry. I really wanted to understand that. That's cool. I like that a lot. It's a great feature. Okay, so you can use Markdown. Xcode formats and displays info as quick help when you view it. Yes, it does. Yeah, I love that. I love that. Xcode also formats quick help from multi-line comments that begin with and end with. For more information about the markup syntax for quick help. Ooh, yeah. We need to save that. I don't think it... Yeah, it doesn't like my... Dude, fucking refresh. What is it doing? Okay, it just doesn't want to do it. All right, well, fuck me then. Guess we'll just do it a different way. Markup overview. Actually, maybe I'll just... I can nerd out on this later. It's not really conducive to moving it along with Swift specifically. So yeah, I'll come back to that. But I think that's good enough that people know that you can do it. So if you're a Markdown fan, you can use it. If not, yeah, fucking ignore it. I strongly recommend typing the code I present. Do it. Wait, we read that. Structuring data. Okay, here we are. The date type comes from the Foundation framework, which contains Numerous useful types for app development. Whenever you require a data type not offered by the Swift standard library, consult this framework's documentation to see if Apple has already implemented it. Oh, I see. Okay. So if not in the Swift standard library, check the foundation framework. Is the foundation framework in Swift? I don't think it is, but historically, the foundation framework in Swift was largely written in Objective-C. However, Apple has been actively working on a new open source implementation of Foundation written entirely in Swift. Oh, that's awesome. I wonder where that stands. That's really good news. Okay, the future of Foundation. Yeah, because I know people were... That was one of the things when I was researching it. They were kind of... Well, it seemed like there's two houses, you know, or two schools of thought. The existing devs and the new ones. The new devs like that, you know, on Linux, if you were going to go write a web server or something along those lines, an API on a Linux server, they liked, you know, if let's say it's a grassroots project, they liked not getting the foundation framework inherently with Swift, that is the case on, if you're writing Swift on an Apple platform, it's just there. Foundation meaning. But they didn't want that big hefty arse foundation framework coming over with it. And so I guess this was the solution, just rewrite it in Swift. So that's awesome, but unified foundation implementations. This helps avoid, yeah, no more wrap C code. That's awesome. Ooh, what's that little, current state. As of June 2024, oh, that's, it just happened. Apple is actively developing and releasing updates to the new Swift-based foundation framework. Really? Where is my, come on, man. Where's my, I think my shit is struggling. What is this doing? See, this is why I regret getting the 16 gigabyte MacBook, honestly. Truly. Can't save my... That's really annoying. Let's try it again. I think it just doesn't register when it's too big. Where did it go? Still not there. Yeah, it's fucking annoying. All right, using the Swift Foundation package, but I want to go follow this. Let me just star this for my GitHub account. I'm just curious what Swift and C. It's not many issues, that's good. See how many bugs there are. Bugs on one for Linux. Two. Runtime crash. Oh yeah, we hit that one. That was annoying. Looking to test. Number formatter. Okay, good. I was hoping this would be the case. It looks like we've come at a good time. A lot of the pain. Looks like they've gotten over the hump. Maybe we will learn. Yeah, we'll probably just do a C stream just because. And I mean, Odin should be pretty easy to pick up after C. So I think we'll do that next. Just referring to what we'll do after we get through the next book. So that's a long ways off, but it doesn't matter. Foundation provides a base layer of functionality useful in many apps, including numbers, data collection, dates, and functions for task management, file system access, and more. Okay, yeah, so I will need to keep an eye on this. Current state, the package is a work in progress that aims to build a new and unified Swift implementation of Foundation for all platforms. Okay, still considered in its early stages. The following types are available with more to come later. Data, date, data internal, encoder, decoder. But, I mean, either way, I guess you could still... I mean, if you wanted to use this and then just keep with pure Swift, you could just... Oh, wait, but the Objective-C version isn't open source. I see. Okay, never mind. I was going to say you could just go implement it yourself, but we don't necessarily know what it is. But I mean, outside of, if we have UUID, that's what I would need. JSON, encoder, decoder. Hey, maybe we'll even use gRPC. Data and date. String manipulation. I mean, I don't... This looks like all of the main offenders already there. Performance. Being written in Swift, this new implementation provides some major benefits over previous C and Objective-C versions. Okay. No more bridging. That's great. Date formatting using format style also comes with major performance upgrades showing a massive 150% improvement. Dang. Codable in benchmarks, parsing test data, improvements in decode time from 200 to almost 500%. Jesus. Benchmarks for Swift Foundation are in a separate Swift package. Governance. Moving Foundation into this future requires not only improved implementation, but also improved process for using it outside of Apple's platforms. Therefore, Foundation now has a path for the community to add new API for the benefit of Swift developers on every platform. Swift's coming on, brother. I think we came on at just the right time. Yeah. I'm feeling some hardcore tribalism swelling up in my belly. I'll be a Swift zealot before long. No, I'll always be a SQL zealot. Everything else is secondary. SQL rules the world. Come at me, bro. Prove me wrong. But, all right, the data type comes from the Foundation framework, which contains numerous useful types for app development. Oh, yeah, we read that. Structuring data is an extensive topic. Wait, let me save this before I... Oh, whoop, not that. This. I would like to save it to Swift. Trusty old Raindrop IO. Best bookmark manager in the game. Just FYI, just saying. Unlimited storage for 30 bucks a year, brother. A year. Incredible. No, honestly, you know one of the coolest things about Raindrop that I really like, that has actually helped me a great deal, is anything that you bookmark. So for example, I just bookmarked this web page, right? If this web page, see that there, little blue check mark. So if this web page ever were to change from the state that it's in currently, as a built-in feature, let me not lie, but I just want to make sure I have it on. Matter of fact, now that I'm saying it. What? Okay, I'm gonna get sidetracked here. But you can add or toggle an option where it'll save the original web page for you. So you can always have a reference back to what it said at that time, effectively, which is awesome. Let's see. Oh, should we get somewhere? Let me Google upload use space. All right, I guess I should clarify. It's unlimited, but you can only upload 10 gigs per month. But you can continuously do that. There's no upper limit beyond the 10 gigs a month. But for a bookmark app, I mean, there's no way you're not even putting a dent in that. Nowhere close. Upload bookmarks. It's somewhere. I just want to make sure I got it on. Backups. Oh yeah, that's what it is. Okay. Yeah, cloud backup. G drive. Might as well. All right, now we'll go back. My fault. Okay, so no. There we go. All right, structuring data. I'll adhere to a simple rule. I'll structure the app's data in the most convenient way for its use in the user interface. Okay. While seemingly arbitrary, this approach stems from an advanced concept called the dependency inversion principle. This is out of scope, of course, but remember this rule when organizing your app's data. Well, I mean, you're not just going to say it and we're just going to ignore it. So let's go see what is that? The dependency inversion principle, DIP. It's not a great acronym. Is a software design. I follow DIP. I adhere to DIP and I'm proud of it. And I've done it for years. I've been dipping for years. Is a software design that promotes loose coupling and modularity in applications. It's one of the 5 solid. Okay, you lost me. That's solid. I don't want to hear that shit. Seriously. Whatever. We'll listen to this guy, but we don't need to dig into 50 acronyms that are just, man, whatever. I get so annoyed with that shit because the second you hit an org, it's like everyone uses the same terms, but it means something different everywhere you go. It's really fucking annoying. Which is why the real value is in understanding primitives and standards, protocols, not Swift protocols, but protocols like HTTP or, Swagger, the open API, standards, specifications, not frameworks and libraries. But anyway, that is out of the scope of this course, but remember this rule when organizing your app's data. However, I may occasionally make exceptions to illustrate specific points better for educational purposes. Yeah, because my whole thing on that is it's better to, if you're going to learn it anyway, just learn the implementation of it and what it looks like. Fuck all the labels because, well, for one, like I said, people get those wrong. So they'll verbally say the same thing. You're verbally talking about the same thing, but you're not. The implementations in your head are very, very different. So it's just a waste of time in my eyes. Because it's all coming from marketing finks anyway. This whole agile bullshit, waterfall versus sprints. I mean, like, what, dude? What a waste of time. Incredible waste of time. One last component we'll need to build our apps interface is actual data to display in our views. My favorite is the project managers. Are you done yet? Are you done yet? Are you done yet? I can't do my job if you're not done yet. I can't do my job if you don't shut the fuck up. When I'm done, you'll know I'm done if you just follow the procedure. You know what I mean? But I get it. That is their job, so that's on leadership. You shouldn't have brought those jokers in the first place, but I digress. The simplest way to instantiate such data is by hard coding it. Every Xcode project contains a preview content folder where you can place preview data for your app that you don't intend to ship with the final product. Yeah, so we did see that with the if debug. We saw a version of that in the sample project or the sample chapter on SwiftUI in the Big Nerd Ranch Guide. So we saw an implementation of that, and that was quite handy. So it's by hard coding it. Every Xcode, yeah, contains a preview content folder. Oh, really? Where? Preview content folder. Oh, okay. See what that looks like. Foundation, settings. Oh, cool. Yeah. What is this? XC assets. Nothing, I guess. Okay, well, that's good to know. All right, so matter of fact, I think I'll grab that one real quick. All right. Within this folder, I place preview data inside a static preview property within an extension for the respective type. I place the preview data inside a static preview property within an extension. Maybe I missed that first part. A static preview property. Oh, right here. Okay. Static let preview equal. Oh, I see. So a type property. Okay. I see. But is he, wait, is he saying this out? He does, because this is the downloadable project, by the way. So I didn't jump ahead or anything. This is just what he provides to download. So that's what we're looking at. But I'm trying to see if, okay, no, so it's just Xcode. It's not something he adds. So it should just be there, which is true because I do vaguely recall seeing it on the others that we did. So that's fine. Within this folder, I place preview data inside a static preview property within an extension for the respective type. This practice streamlines their usage inside SwiftUI previews later. Okay. So in preview data.swift, and then an extension on the type, and then static keyword. I wonder why, let's go ask that. Let's quiz his process against the entirety of the internet. So the simplest way to I just want to see why the static aspect of it. Given the below excerpt from the course, can you explain why the instructor choosing to use static properties here versus non-static? Preview data nature. Preview data is inherently not tied to specific instances of a class or struct. It's meant to be shared and used consistently across multiple previews. Static properties align perfectly with this concept as they belong to the type itself rather than individual objects. Okay. Simplified access using static properties within an extension makes accessing the preview data extremely convenient. You can directly refer to it as the okay, that is a good reason. Directly my type.preview data within the previews without the need to create instances. Oh, that is a big deal. Okay. Consistent behavior keeps your code well organized. All right. How now, brown cow? So export. Oh, I can send it directly to docs. That's pretty cool. I guess there's not a way to just, I thought I could just grab the whole thing. Oh, I can. Okay, good. That's, yeah, that's really what I wanted to do. Yeah, I might have to go check out pricing and put this on the market, this MacBook, because wait, this was using static types for reviewed data. It's all black for some reason. White. Yeah, I think I'm gonna do that. Maybe we'll go to Best Buy today. Look at a Mac Studio or something. Because now that I have an iPad Pro, I just don't. Other than this stream, I don't use the MacBook like at all. All right, let's see. Preview content. We can place preview data within this folder. I place. Okay, we read that, and we saw the example data. That was helpful, and that's the end of that lesson. Okay. Complete lesson. Using forms to style a whole screen without providing layout info. All right. In the previous module, I emphasized avoiding using basic SwiftUI types such as text and image combined with stacks solely as a last resort for view layout. Avoiding using basic SwiftUI types such as text and image combined with stacks. SwiftUI types combined. Oh, right. H stack, Z stack. Yeah, okay. As a last resort. Let me clarify. It's not that these essential elements should never be used in your apps. They are frequently necessary. However, the point is to explore better alternatives first rather than immediately resorting to the most straightforward layout constructs provided by the framework. Okay. Always use the most specialized views for your interfaces. Developers transition to SwiftUI from UIKit. Oh, no. Developers transitioning to SwiftUI from UIKit. UIKit was the, I guess you could call it, it's now the old head. SwiftUI before SwiftUI, but not as good as SwiftUI, in my humble opinion. Experienced having only rudimentary functionality and often needed to build complex controls or layouts themselves. Regrettably, this approach is still prevalent in much of the online SwiftUI material. Damn, he's coming at y'all's head. Y'all suck. Only his course is good. Primarily authored by those accustomed to UIKit. Contrarily, SwiftUI is designed to offer a wide array of standard control and layouts to expedite app development while retaining customizability. This may be evident when considering specific controls, but there are other less conspicuous views that should be standard in every SwiftUI app, yet are frequently overlooked. Shame on you guys. The key takeaway from this lesson is to always seek specialized views to implement your user interface before settling for a detailed layout before settling for detailed layout descriptions. Okay. Well, if it's key, it's key. Save highlights. Man, this app is so good. It's just a single dev, but it's pretty incredible. This is for... I remember him saying, he's man of his word. He said he would add this. This is very helpful. So this does take Markdown. So Swift UI. Okay, I wanted a space, but that's okay, brother. It's good enough. It is, in fact, okay, there we go. Can I, oh, it's just single line. Okay, that's all right. SwiftUI, I'm just going to call it label them ism. So I can aggregate these later. Xcode tools for custom SwiftUI view implementation. Xcode tools for custom SwiftUI view implementation. To illustrate this concept, let's implement a prevalent iOS user interface for our app settings. Let me get, yeah, that's fine, it's good enough. Prevalent iOS user interface for our app settings, personal information.swift. Now, is this in the file yet? Home. It is. Okay, I don't know if he's, I guess we can, or he's just not saying it, but here's the code, so I guess it doesn't matter. Okay, so personal information.swift is the file, source code file in the project itself. This is a struct, so it's of a value type. It's named personal information, and this syntax :view says it conforms to the view protocol. So then the first squiggly and last squiggly define its scope, so everything in between belongs to this type, personal information. So then we have a let person, so that's a constant variable, meaning once initialized it cannot be changed, and it's named person and it's of type person. So there's some definition predefined for what a person represents. Hence the, because you see this a lot, we've seen this over and over and over and over, and I get it. I still just kind of, I guess it's a necessary evil at this point, because I don't disagree with the approach, but seeing the little, you know, the variable and the type, yeah, you know, but I get it. I get why it's necessary. But yeah, so you see that a lot. So there's the type, which is the definition, and then there's the instance, which is the what we call the variable. But in this case, it's a constant variable. So that's kind of why I never, you know. Honestly, if I'm really thinking out loud, I just wish they would have went with const, but it's not a big deal. So this is how we say constant variables, as in once initialized, they can't change. And then if we want a mutable variable, I really should use those terms. So yeah, so let is, so immutable, cannot change, and that's equal to a let, which, and then a mutable means it can change, and that's a var. So that's what those, a var, that's what those two are. But in both cases, where can I put this? In both cases, they are, we call them variables, which I guess is technically true. I mean, it can vary what the immutable variable might turn out to be initialized as, so maybe that's why they call it that. But either way, that's just it is what it is. So they're, let and var both define types of variables, but the let is immutable. Once you initialize it, can't change afterwards. If we use var to define the variable, keyword var, it's mutable, which means it can change. All right. So var body. Yeah, I just wanted to say that because I keep using the different terms too. And I'll probably keep doing it, so I just want people to understand what I'm saying. Yeah, so a constant, I'm just going to call this a constant from now on when I see it. Instead of saying a immutable variable, I'm just going to say constant. And then if I see a var, I'm just going to call it a variable. But just know that both are variables. But for whatever reason, that's what wants to come off the tongue, so we're going to go with that. Okay, so we have a constant person type, and then a a variable body, and this syntax we saw is the opaque type. So this is the keyword sum. It's a placeholder for, so kind of like with generics, how you can have, you know, the pokey syntax, and like inside it, it'd be type T, which just means literally any concrete type could be in place of T. Some view is more or less the same thing, but it's more, well, for one, it only applies to protocols. So view is a protocol. So some applies to protocols in Swift. And when we see, like in this case, some view is equal to saying the type that will be used here will conform to the view protocol. That's what it's saying. That's what an opaque type is. Oh, right, and I didn't put that there. So the term they actually gave us is opaque type. That's what describes that keyword, some view, or some anything. So if you use the keyword some, you know that you're working with protocols. You don't see it anywhere else. And you also know that it's saying that whatever concrete type ends up being used in this slot will conform to whatever protocol. In this case, that protocol is the view protocol. Okay, so like generics, but with some constraints and always applicable to protocols only. All right, so now that we understand that, inside we got so these are also views. So we also learned that SwiftUI really refers to, like if you're coming from web dev, which that's my reference point here, the way that they use the view term in terms of the definition is the way that HTML more or less refers to elements. It's like a label, a div, you know, a nav bar, a vertical stack, text even. The text type is a view, label is a view. So it's not, initially I was thinking view meant the entire viewing window, but that's not the case. So it's more closely defining how HTML refers to elements, you know, in the DOM. All right, so this is 3 different views, or no, more than that. So 1, 2, and then labeled content, and then inside of it, you have additional views. So lots of nested action here. So you have a label, name, system image, person. Okay. And then all of these dot notations beneath each of these are modifiers we learned, which are just methods that belong to a particular type. So there are some that are global, like some will, I don't know if badge is one of them or not, but we learned that some modifiers are global, meaning they can apply to any type within the framework of SwiftUI. Others are specific to certain types, like one example would be the dot font only applies to, or no, sorry, maybe not font. I think it was bold, one of those. But that would be an example of one that only applies to text and not everything in SwiftUI. So there are both. But I mean, the editor is going to tell you if it works or not. So I don't think it's a big deal to navigate what's what necessarily. Let's see. So we call the modifier with the nested view person.name. So this is saying we just want on the badge to have the first and last name with the space in between. Makes sense. And then labeled content address, which is effectively using a view builder. That's what it looks like. Or more like string concatenation. which is what the plus operator will do when you're working with strings. Yeah, so we're just building a larger string with these components here. Okay. And then multi-line text alignment. So this modifier, since it follows, where is this? Okay, no. Yeah, so this modifier follows the scope of the labeled content. So the multi-line text alignment trailing, which we learned, that was one difference between what SwiftUI calls something and what you may have seen it called elsewhere, but the dot trailing is equal to the right justify. Like if you ever use Word to push your words over to the far right versus center versus left justify. And then leading was left justify. And then I think center dot center is centering it. But yeah, so that was just a minor difference, but something to be aware of. So we're saying that for all of these view, or for this string that we're building in here, we want to have the trailing or the right justify formatting applied to it. And then here's the preview. They didn't want to call it a macro. It's not technically a macro. We'll just call it a feature. We just know that the pound preview keyword automatically opens this little preview. So if we look at it down here, the hash preview, that will automatically, it's strictly for use in Xcode, doesn't mean anything to the compiler, but when you do this, it's a way to quickly just wrap and see a preview in a window like this. So if we were to comment out the preview, then the preview window goes away. So easy enough. So that's just for our developer convenience, because we're important and we deserve nice things. And so now we go, oh, that's what it builds. Okay. Yeah, okay, yeah. Yeah, I really like, this is really good. I mean, by comparison, I'm not hating on other things. I'm just saying, I think HTML and CSS got it right a long time ago. And there's been a big move towards like lots of like Golang. Let me show you just real quick aside. Shout out my Go folks. So for Golang, if you write Go or are interested in it and you want to write desktop apps or even mobile apps, you can write mobile apps using this. This is a project, whales.io. It's open source, free to use, blah, blah, blah. It's a great project, though. The cool thing about it is it embeds a browser. So Go lets you embed assets and whatnot inside the binary. So you can compile just a single binary file when you write your app, and it can have your, your backend. And, if you use SQLite, you could have a fully unique app that can run on any platform, right? And it can embed your front end because it can embed the browser and all your assets. And so then you can just write HTML and CSS and have a Go app. So it's pretty sick. So I would say definitely come check it out. There's lots of like reference projects and community templates to help you get started, but it's a great little project. But I'm calling that out because even, open source, a lot of the open source GUI tools that you see popping up that are not first party but get popular seem to follow this paradigm. So I like that SwiftUI is really close to web standards in the first place. I just think it makes sense. And it's declarative. I mean, you can pretty well tell what's going on. It's not entirely too difficult to tell once you understand the syntax and whatnot. And this is what we get. So name, John Doe, and then you can see the trailing because it's all right justified. So that's the output there. Wait, how did they get the icons though? Where's that coming from? Is that... doesn't seem to... I guess that's just kind of not there, but that's okay. I prefer typing code as it is faster and allows me to utilize code completion. displaying available initializers, properties, and methods for each type. Refer to fixing issues in your code as you type article for more info. I prefer typing code. How else do you... I'm not aware of any other way to do it. Oh, you had to type the code. In bottom split screen. Fixing issues in your code as you type. Minimize typing related errors using code completion and let Xcode fix common mistakes for you. Overview. Xcode includes a number of features that help reduce typical coding mistakes, such as when you misspell a symbol name or forget to add a closing delimiter. By leveraging these features, you can focus more time on adding value to your app and less time fixing easily avoidable issues. With your explicit consent, Xcode can help you locate the correct symbol, fix common errors, and automatically match braces. Oh yeah, okay. Parentheses and brackets by directly changing your code. Avoid syntax errors by using code completion. Excuse me. Oh, not tired, you're tired. When you begin typing the name of a symbol in the source editor, Xcode displays a list of suggestions for completing the name. You can dismiss this list by pressing escape or clicking elsewhere in the source editor. Yeah, we saw this. So I think, let's see what else they got. To insert a suggested completion in your source code, select the item and press return. Or you can double click. Yep. If the inserted symbol contains parameters or arguments, Xcode adds a placeholder for each one. Use the tab key. Oh yeah, we talked about that earlier. Match braces. Immediately after an opening delimiter to temporarily highlight the closing delimiter. Yep. Yeah, I mean, a lot of this stuff is kind of intuitive, so you kind of just come across it. So I won't harp on these. Make a fix connection. Oh, correction. Yeah, when you click on the error, if it can fix it, it'll give you the option. So that's pretty straightforward. To use fixit, you must build your target with either the LLVM or Swift compiler. Fixit is compatible with Swift, C, Objective-C, and Objective-C++. Oh, cool. All right. Nevertheless, Xcode also enables interaction with the preview canvas when constructing interfaces. Further details on these features are available in the Creating Your Apps Interface with SwiftUI article. Okay. Develop apps in SwiftUI with interactive preview that keeps the code and layout in sync. Yes. If you choose the SwiftUI framework to develop your app, you can see an interactive preview as you lay out your user interface. Xcode keeps the changes you make to the source code, the user interface layout, and the inspector in sync. For example, when you edit attributes in the inspector, Xcode adds the corresponding code to the source code file. That's helpful. Sometimes, I mean, I would say most times I'm with the author. It's nice to just write the code, especially when it's declarative like this, but every now and again, and they're talking about, see if I can get this. It's building it. There we go. They're saying you can use this, the inspector over here. Is this it? Yeah. So if we click, why don't I see it? There we go. Yeah, so name, instead of name, how about lame? That changes. There goes lame. Yeah, but see, I mean, sometimes it's nice to just hop through the boxes, maybe, or just change the code, you know, whatever. But yeah, so that's nice. That's nice to see. Displaying the SwiftUI preview to show, select a file that uses SwiftUI in the project nav. Yeah, I mean, it's just going to open. We saw that, so we understand that part. So we won't kick that horse while he's down. Use the controls at the bottom of the preview to run the app on a simulated device in the canvas with or without a debug session, or run the app on a connected device, which is pretty sick. So maybe we'll try that out tomorrow. Plugging up. I'll have to figure out a way to get that on the stream. I'd like to show the process, but yeah, that's pretty cool. So, I mean, more than likely, you also have an iPhone, so you can just test it right there on your device. You don't have to use the simulator, which is nice. I wonder if device, nice. Okay. I wonder if, because I know the simulators take a lot of memory, so maybe that's a way to offload some of that work. We'll see. Add views and modifiers to your app. Click the library button in the toolbar to open the library, and then drag the user interface elements from the library to either the canvas or source code. Really? Regardless of where you drop the elements, Xcode keeps the source code and the layout in sync. So you're telling me I can just drop this here? How about a gauge? Lies. Where did it go? Nothing happened. Let's try it again. How about a button? Okay. Oh, I can't do that though. Gotta be... Here probably is cool. And there it is. Well, that's cool. That's really cool. And convenient. All right, edit user interface elements. Edit element attributes using either the action menu or the inspector, or by entering code in the source editor. Okay, yeah, we saw that. Embed user interface elements. Additionally, you can modify the user interface by embedding elements in other structures. Command click an element in the source code or in the canvas, then choose an embed in generic structure action from the pop-up menu. For example, choose embed in HStack to embed an element that arranges a view's. You can modify command click, huh? Okay. Trying to get the fucking... Okay, there we go. How about command click? I don't think I changed my defaults, but they keep saying command and it's control for me, but okay, there it is. Yeah, and speaking of, where is my Keystroke Pro, man? Why didn't it start up? Launch on app. There it is. Now it's showing. Okay. Yeah, so command, or sorry, control, click. And where is embed in HStack, VStack, ZStack? So I don't have the... Oh, maybe it's here. That's still really cool. Okay, so HStack. Man, all right, brother, shoot. Very cool. All right, then, okay. Well taken. To learn more about SwiftUI, go to introducing SwiftUI. We don't need to do that. We're doing it right now. Entity forms. Forms offer standard layout and styling out of the box. There's much to unpack in the code snippet above. Let's proceed systematically. The notable aspect here is the absence of color or layout specifications. Consulting the Picking Container Views for Your Content article reveals that SwiftUI offers numerous containers beyond simple stacks. Okay. Well, yeah, first of all, save that. Oops. And we want to open that bad boy up there. Build flexible user interfaces by using stacks, grids, lists, and forms. SwiftUI provides a range of container views that group and repeat views. Use some containers. Wait. SwiftUI provides a range of container views that group and repeat views. Okay. Use some containers purely for structure and layout, like stack views, lazy stack views, and grid views. Purely for structure and layout, yeah. So they render nothing themselves. They're just tools to control other views. Use others like lists and forms to also adopt system standard visuals and interactivity. To also adopt system standard. Okay, choosing the most appropriate container views for each part of your app's user interface is an important skill to learn. It helps you with everything from positioning two views next to each other to creating complex layouts with hundreds of elements. Okay. Group collection of views. Stack views are the most primitive layout container available in SwiftUI. Use stacks to group collections of views into horizontal or vertical lines or to stack them on top of each other. Use HStack to lay out views in a horizontal line. VStack to, I feel like we looked at exactly this. No, it was a bit different. It just had that first portion. Okay. Yeah, so a Z stack. This H stack is wrapping this V stack, which has two text elements in it, which are this Rachel Chisek and her title. And there's the image, obviously. And that's all wrapped by the Z stack. You often use stack views as building blocks inside other container views. For example, a list typically contains stack views with which you lay out views inside each row. Okay. For more information on using stack views to lay out views, see building layouts with stack views. Repeat views or groups of views. You can also use HStack, VStack, Lazy Stack, and Lazy VStack to repeat views or groups of views. Place a stack view inside a scroll view so your content can expand beyond the bounds of its container. Users can simultaneously scroll horizontally, vertically, or in both directions. Yeah, I think we've all encountered apps that let you do that, and it's a beautiful thing. And really, it comes to be, I mean, especially on an iPhone and iPad, it comes to be more or less expected, to be able to do a lot of those things. Otherwise, you're like, man, this app is trash. Stack views and lazy stacks have similar functionality, and they may feel interchangeable, but they each have strengths in different situations. Stack view loads their child views all at once, making layout fast and reliable because the system knows the size and shape of every subview as it loads them. Oh, yeah. Lazy stacks trade some degree of layout correctness for performance because the system only calculates the geometry for subviews as they become visible. Yeah. Yep. That's lazy loading has made its way to web dev too, so that's pretty cool. Where it's incrementally loading the web page based off what's literally in the viewing window. So if it knows it's coming up on other things, like as I scroll down slowly, it's loading things in the background. That's why sometimes if you scroll down really, really fast, you see those skeleton kind of black and white grayed out images until the actual image loads. That's just it's a placeholder until the real data is there. which is a nice little technique. Grids are a good container choice to lay out content that naturally displays in square containers, like a gallery. Yeah, like an image gallery. Grids are also a good choice to scale user interface layouts up for display on larger devices. For example, a directory of contact info might suit a list or vertical stack on an iPhone, but might fit more naturally in a grid layout when scaled up to a larger device like the iPad or Mac. Makes sense, yep. Like Stack View, SwiftUI Grid does. Wait. Like Stack View, SwiftUI Grid views don't inherently include a scrolling viewport. Place them inside a scroll view if the content might be larger than the available space. Okay. That's good to know. Let me save that. Yeah. Wait, what? Why not? Let me reload this. Why can't you save it? I really need you to do it. Maybe if I... Boo. Okay. Well, whatever. Fuck me then. So display and interact with collections of data. List views in SwiftUI are conceptually similar to the combination of a lazy VStack and scroll view. List views in SwiftUI are conceptually similar to the combination of lazy VStack and scroll view. Okay. But by default will include platform appropriate visual styling around and between their contained items. Okay. For example, when running on iOS, the default config of a list adds separator lines between rows and draws disclosure indicators for items which have navigation. And draws disclosure indicators. Cool. And where the list is contained in a navigation view. List views also support platform appropriate interactivity for common tasks such as inserting, reordering, and removing items. For example, adding the onDelete perform modifier to the for each inside a list will enable system standard swipe to delete interactivity. Yeah, we saw that in our big nerd sample, so that's pretty cool. Like lazy HStack and lazy VStack rows inside a SwiftUI list. Like lazy HStack and lazy VStack rows inside a SwiftUI list also load lazily, so not all at once. And there is no non-lazy equivalent. Okay, list inherently scroll when necessary, and you don't need to wrap them in a scroll view. Okay, so lists are our friends, apparently. And group views and controls for data entry. Use form to build data entry interfaces, settings, or preference screens that use system standard controls. Okay, that's good. Forms are also an HTML element, so that's really close to web standard there, so that's nice, keeping with that. And this is a form, which we see these quite often. Yeah, so that's nice. Okay. Like all SwiftUI views, forms display their content in a platform appropriate way, the Apple way. Be aware that the layout of controls inside a form may differ significantly based on the platform. For example, a picker control in a form on iOS adds navigation, showing the picker's choices on a separate screen, while the same picker on macOS displays a pop-up button or a set of radio buttons. Yeah, so I guess there's your answer for why sometimes when ports happen, behavior changes, and it's like, what the fuck? But I guess that's why. It's not always up to the dev necessarily. Or I guess maybe you can write you could write your own custom implementation, but is that really, do you really want to wait for that port, 2 more months for them to do that kind of a thing? So, yeah, peeling back the curtain a little bit here. But yeah, I think that is a good stopping point for today. I'm gonna plug it down. Wait, what section were we on? Form. Yeah, okay, forms. We'll just call it forms in 3.2. And drop that on the board. And then we can just pick it up there tomorrow. I'm gonna drop my little reminder image. And then I'm gonna go to Best Buy and see what kind of deals they got. Can you, whatever, that's good enough. Okay, guys, per usual, please drop a follow on whatever platform you're checking me out on. We'll be back tomorrow around the same time. I'm trying to pick a better, maybe I'll push it to noon. How about that? I'm just gonna start calling it 12 p.m. Central Standard Time. That'll be the kickoff point. But we'll be back tomorrow, 11 or 12. I'll pick a solid slot soon enough, but it'll be some point in time there while I get things sorted. So we'll be back tomorrow. And then also check out my Halo stream if you're into that. If you want to watch me game and fight with a bunch of oily nerds. I have been on though lately. So I'm on the road to Onyx. I got Diamond and Ranked Doubles, Ranked Arena, and Ranked Slayer. You know, am I bragging? Yes. Am I proud of it? Yes. So come check that out. That's always a good time, 9 p.m. Central Standard Time for a few hours. Otherwise, I'll see you guys tomorrow. Take care of yourselves and each other. Go hug somebody, drink some water, eat some lunch, and, you know, get to bed on time. All right. Goodbye to you.